Welcome to next session on Arduino based systems. We shall continue our discussion to elaborate the further details of working of microprocessor. I will try my level best in sessions, this session as well as sessions to come, to make you understand how microprocessor works. Study of actual microprocessor, its architecture, its programming, its assembly. And now what has happened that some means as you grow, I will give you an example. Suppose if you are having very small industry, managed at family level, then what is done? All kinds of activities required are done by you. Everybody can participate in the production process and can do the things right from raw material to the finished product. Everybody can do all things. But so you need to know details of so many processes. But as you grow big, then what happens is that there is a concept of outsourcing. Means at a top level, you simply have a broad picture of what is to be done. And you actually don't do anything. That is managerial work. Even in industry, when you go, say you do coding at initial stage, at latter stage of your career, you will not do coding. It's managerial work. You will manage the people who work for you. So like that, say around 3-4 decades back, ability to write down the assembly language program for given application was considered to be a very big skill set. That time, computers means what happened that what we can say paradigm shifts, sea changes because of computerization. Computer in the form which you have today has grown very rapidly, and it is a recent invention, we can say, or recent happening, we can say. So there were many things which were existing before the computer became available in the present form. So when computer was not there at the fingertips of the user, that time also microprocessor based systems existed, and that time the designers, those who were working, developers, were required to know assembly language programming, or even machine language conversion was to be done manually. Then assemblers came, which were microprocessor based programs, also which were computer based programs, assemblers, which converted assembly program into machine code. And then cross compilers came, and now you can do everything in C language, or it is so advanced that you write at a abstract level just like computer programming. And in Arduino system, what you in the practicals might observe that, even though you could not get the privilege to actually do the practical, but by observing you could have understood to some extent that at a higher level it is to be done, and converting it into the code of a particular microprocessor is done automatically. To this extent, automation has taken place. Therefore, the subjects like a particular microprocessor, say Intel family microprocessor, Motorola family microprocessor, or Xerox Corporation that nowadays, that time 80, 85 and Z80, which were what we can say as good as clones of each other, was much popular. So that kind of expertise is now not needed. We need not waste our time in learning a particular processor in detail. But what has happened because of that, as I said, that again repeat, why at least it's what we can say, broad overview is needed. That a question was asked to Mukesh Ambani about the significance of tables, padhe partane, be ke be value char, 2 ones are 2, 2 twos are 4, 3 threes are 9, like that. When calculator is there with you, what purpose it serves to remember tables by the students, school going students? Then Mukesh Ambani replied that I know that the memorizing tables will not give any kind of advantage, because whatever they can, for doing something which prior these tables were required earlier, now with calculator that is memorizing tables is now no longer a necessary condition, because your alternatives are available. But I look it at from the angle of development of some kind of faculties of human brain. If everything we start forgetting and we means tools are our servants, but if we decide to be over dependent on these tools, then a situation will arise that instead of tools being our servants, we have become the slaves of the tools, that we cannot do anything on our own. That should not happen, and for that not to happen, at least a broad overview of microprocessor, its internal architecture, instruction set, various what we can say details of the types of instructions and how the program sequencing is to be done, what exactly happens inside microprocessor. All those things are required at least an initial first year stage, so that you get a complete overview of how microprocessor works. Then what is expected is that, see, everything need not be understood, that even super specialist doctors may not understand why a particular human cell is a lively entity. But what do is that they are expert to stop from where not to think, and to think to its extreme, what we can say, understanding point. So yes, up to this I will try that defining that boundary or defining that threshold of what we can say understanding and presumption is very important. If you decide to presume everything, there is no need of learning, and if you decide to understand everything, you cannot learn. That means in the first case there is no need, in the second case there is no possibility. So you have to be on a proper boundary, up to which I will try to understand everything, and beyond which I will not pain myself in understanding, and I will assume everything. And the boundary of assumption between assumption and understanding is not a static boundary, it is a dynamic boundary. Where when at a childhood stage you presume everything, almost everything, and as you grow you try to enhance your understanding boundary and stop somewhere. So like that, the microprocessor, we will have a suitable boundary to which we will attempt understanding. So I will throw some more light on functioning of microprocessor programming, how things are connected, and I will take some small application of microprocessor. As I already stated that Arduino, as what is Arduino again, I repeat, then you will say, oh sir, our subject is Arduino and why you are repeating a microprocessor? Arduino is what we can say simply an alternative name of a microcontroller family, and microcontroller is microprocessor plus, means say 30-40 years back microcontrollers were not so popular. Microprocessor and peripherals were required to be connected as microprocessor based system. Microprocessor based system was elective at the final year. Then as there was progress in VLSI, many things could get occupied on a small silicon, in a small silicon chip, and then microprocessor and peripherals were pulled together in a single chip, that is microcontroller, and its today's version is Arduino. So we must know the functioning of microprocessor, which is what we can say pivotal point, which is as good as heart of this Arduino based systems. So I again repeat that what I am trying, the thing which is otherwise very difficult, which was otherwise very difficult to be understood even at the third year or so, few decades back, now I am trying to explain it by using some kind of assumption, some kind of abstraction to first year students. So what is a microprocessor? Microprocessor is a digital chip comprised of various logic gates only, huge number of gates, so that it is having from outside, it is having address lines, let us say 16, 8 data lines, and inside is having various temporary locations called as registers and an arithmetic logic unit. Arithmetic logic unit is, you have seen adders, subtractors, that kind of complex element is there. So now what I will do is, what kind of, to be very precise, we will develop, see, those who were having 12th vocational computer science, they were having 885 at microprocessor as a part of their syllabus, but for others it's not there. So in the last lecture I have told you how sample instructions are designed. We will design an instruction set, ultimately how microprocessor works. So with the, what we can say, small information provided to you, you should be able to work further. What microprocessor is? Microprocessor is a digital circuit which consists of some internal memory locations of 8 bits each, paired as a register pair in some cases. These are called as registers. These are internal memory locations. So, now, try to listen carefully. I again repeat that today the information is available to such an extent that there is almost flooding of information. So, the purpose of classroom session is not to give information that you can get anywhere else. The purpose of classroom session is to simplify, or we can say, it is said many times that conversion of information to knowledge, that is at a higher level skill. But what in the classroom, what is expected? Interpretation of the information. So you are in the first year, but we will develop the instruction set of the instead of see. Now, in today, the problem faced by today's generation, who are somewhat genius, somewhat interested in doing some things on their own, that maybe in the last century, one will say, yes, I will do this research, I will find out this thing, I will find out this thing. Very much passionate people were there. But today the problem is that the moment at which you decide if some idea is coming into your mind, if you conceive an idea and yes, I will find out this, I will find this new thing, it will be my invention. You might be knowing that Edison and Swan both have invented incandescent lamp independently of each other almost at the same time. But today the problem is when you start inventing, there are many, what we can say, in fact, how to do research, what is research, intellectual property, patenting and all that thing, there are advanced courses. But the simple thumb rule what I will tell you is that I don't know whether you are so much passionate in research. Do you feel that yes, my name should be, my footprints which I will leave with this world should be like that of Einstein, Niels Bohr, Heisenberg, like that. So if you are having so passionate about research, new things, and some totally new things come to your mind and you start thinking on that to work, first what you should check is you should do a Google search. For what? To check whether you are not wasting time unnecessarily that might have been done by somebody else. So the problem before a genius researchers today is that they will find that almost everything is done by others what is for me to do. So that means few decades back there was frustration of shortage of few things, just like a drought situation. Whereas today the frustration before genius researchers is that abundance of everything. It's just like a flood situation. Korna dushkal and ola dushkal. Whatever I think, it is already done. Then what should I do? Remember that out of Edison and Swan, who has invented the incandescent lamp earlier is not known. But its patent, its credit was given to both, because since they were working in a disjoint manner, one can say it that nothing is after the other, both are simultaneous. Similarly, what we should do is that if you get some clicking idea, you work on it. Spend some time, develop something till you get satisfied, and then have Google search. And if you find that something else is already there, but which you are not knowing, it is as good as you have independently invented it. And once this, what we can say, attitude gets developed within you, I don't know whether you are exposed to the vision of this institution to produce capable graduate engineers with an aptitude for research and leadership. So research aptitude is important. Therefore, even though the instruction set, even though 8085 is already existing, what we are doing, even though 8085 is already existing, what we are doing is, we are developing the instruction set. We are developing the microprocessor. We are developing the microprocessor. So that you should get a feel, yes. And after this lecture, you can I will give some further introductory part, then you can put a pause and you can also simultaneously think on the instruction set of microprocessor. What is microprocessor? What is instruction set? How it works, how it is arranged, how it functions, and all that, right? So, what microprocessor does externally? Microprocessor externally can have a read cycle or a write cycle. So if you look externally on this, then every time either reading from somewhere, something comes on data lines, or writing something somewhere. Reading from somewhere and using the thing somewhere means somewhere. Remember now. It's a very interesting question. It's a very interesting question, and if you are able to answer that, you would be super genius. Suppose if only this microprocessor is put in the system, obviously supply lines are there, and nothing is connected to microprocessor, what will happen? And nothing is connected to microprocessor. Are you getting me? If microprocessor is only connected and here memory is in a system, we say that there will be memory. There will be. It doesn't mean that there has to be. So if you simply have a simple microprocessor, 8085, and it is 8085. Just we have assumed for simplicity. And we have it, we reset, we switch on the microprocessor, we reset the microprocessor, and we deactivate reset. So we make the microprocessor to start from the initial state. Nothing is connected. It is just like for other subjects you are watching, you are participating using Microsoft Teams. So for a teacher, he thinks that all students are live with me in the classroom. But the mischievous students, what they have done? They have just logged in and left. So there is no way for the teacher to know unless he is very much inquisitive and takes attendance like that. Otherwise, for teacher, there is no way with which he can understand whether the students are there or not. And he can go in an empty classroom and start talking. Like that, for this microprocessor chip, there is no way with which the microprocessor chip can understand that whether the memory is connected or not. And suppose if you decide to fool the things, then what will happen? Those who want to answer on their own can put a pause. Think in a rigorous manner, because this is a very interesting question. A very interesting question. What is going to happen in case of microprocessor when nothing is connected to it? Then those who want to answer can answer. Think on their own after putting a pause. Otherwise, you can watch it again. Now, what will happen? Microprocessor doesn't know the existence of the memory. and it need not also know. So what will happen? After reset, it will have a read cycle. It will have a read cycle. So it will have a read cycle means what? It will put address on address lines. It will put address on address lines. It will activate read bar. It will activate read bar. Something is expected to put the data on data lines, that it will take further. But if nothing is put, if no device puts anything on data lines, microprocessor is treating data lines as input lines. Nothing is put by just assume now, because there is no point in going into its details. When nothing is put on data lines or on input line, when it is treated as high, logic high. So if a microprocessor which is now hanging, nothing is connected, puts 0, 0, 0, 0 on address lines, and as I have already stated that the first cycle after reset is an opcode fetch cycle, because if that is not an opcode fetch cycle, then what next cycle should be always remain a question. So after reset, microprocessor is going to read the memory location 0 and is expecting the opcode. So F, what it will read? All high. All high is opcode FF. So when nothing is connected to microprocessor, it will take it as all ones as the opcode and proceed further. It will take all ones as the opcode and proceed further. And when it proceeds further, what it will do? It will take it as an opcode, what that instruction is. It will complete that instruction, that what that instruction is, and other things that I will explain in the next lecture, next part of the lecture. It's very interesting. I am trying my level best to give a new approach to the entire subject. Thank you.